All right, so we are on lesson 6-1. We have 3 lessons this unit, so nice and short. Today's date, let me change the zoom here. Today's date is Tuesday, December 10th, 12/10, 2019. Slope fields. Our objective today, who's going to read it?
Sketch a slope field given first derivative.
Yep, there it is, derivative. So I'm always going to be giving you some dy dx. That means I'm giving you the first derivative. And it will probably have an x and a y, and sometimes it'll just have an x. And you're going to be plugging in a bunch of points. So the way that I read this one is I say, I'm looking at the derivative when I plug in 1 for x and 1 for y. I'm plugging in 2 for x, 3 for y. That's always the x and y coordinate. You won't see that notation on the AP test. That's just my way of telling you what you're plugging in. So let's try that. Let's say my first derivative is x times the quantity of y minus 1. Let's plug in 1 for x, 1 for y. What is the value that I get out? 0. There it is, yeah, because it's, if I plug in 1 for x, it's 1. And if I plug in 1 for y, it's 1 right here, minus 1. And 1 minus 1 is, this all goes to 0, so this is 0. Okay, everyone, slope of 0, go with your arm. Good. Slope of 0 is that nice horizontal line. And that's what you're going to be doing. You're saying, okay, well, the slope at the coordinate 1, 1, so I'm going to come down here to the coordinate 1, 1. So that point right there has a slope of 0, which means it would be a horizontal line. Well, we're not doing that yet, but that's essentially what we're going to be doing. So coming back up here, let's plug in 2, 3. What slope do you get? Go. Yeah, 4. So 2 times the quantity of 3 minus 1 is equal to 4. Everyone go slope of 4. Show me. Steeper, steeper, steeper. It's steeper than you think. Yeah, it's like up there. A little bit too steep, Gio, but yeah. Slope of 4. So everyone has a rough idea. I don't think they'll ever ask anything over a slope of 4. It's either between 1/4 and 4, and then sometimes negative as well, right? Let's try this one. If I say that the derivative dy dx is 2x, what happens if I plug in the point 1, 1? I get 2, yeah, because it's just 2 times 1, which is 2. What happens if I plug in the coordinate -1, 0? -2, there it is. So what we're dealing with is obviously the first derivative, which means we're using the first derivative test also. So when f prime, this is really f prime, right, not dy dx. If f prime is positive, what does that mean? Slope is positive. All of this correct. What did you say, Claire? Going up. What is the definition that we know? So if I write out the definition, when f prime is greater than 0, that means it's f. Oh no, we need to review this.
Increasing?
F increasing. This one over here has f prime is less than 0, which means it is what? F decreasing. And then Gio, when I have dy dx at 1, 1, what is that? F. So it's positive. It's 2, right? There it is, yeah, f increasing. Perfect. Cool, so differential equations. The whole idea is we're now dealing with an equation, which means we have an equal sign, and they can be weird letters now. Usually they're going to be y and x, but sometimes they'll be something else. So like you could have, I don't know, dw dt, the derivative of lowercase w with respect to lowercase t, or you could have, I don't know, dy dx, of course. You could have dy dt. dt. I don't know, choose some random letters and put them over an equation and you're good. Give me some other ones. dz, dx. There you go. So if you see one of those, that means you're dealing with something that has a differential part, and then if you have an equal sign differential equation. I think this is the unit where we talk about finding particular solutions, so that's one of the hardest things in AP Calculus. It's super difficult. This is your first lesson, so it's nice and easy. Let's talk about this. So if I say dy dx, that's f prime. That's also known as slope. So dy dx, this is the same thing as slope, and it has a slope of 0. So when dy dx is equal to 0, slope of 0, again, you made it with your arms before, go ahead and graph it now. So just any point, so I'm just going to go right here. Actually, I have technology. What am I doing? I can use a nice blue line. Slope of 0. Make a slope of 1. With your arms first and then write it down. Good, yeah, slope of 1 goes like that. Slope of -1. Good. Write it down. Slope of 2. Yes, it goes right 1 up 2. Yeah, so right 1 up 2. And then negative 2 goes right 1 down 2. Cool. All right, so here's your first problem. Obviously, it would be much harder. Well, not much harder. You'd probably have some sort of parentheses and stuff on the actual AP test. But there it is. dy dx is equal to 2x. So we have to find every single one of these points. We need to have a little bar that represents the slope. And you'll have a lot of these little bars all matched up all over the place for every single one of these points. When we finish that, it is called a slope field. It's a field of slopes.
Like little lines everywhere.
Yes.
This is kind of cool.
Yeah, and
Could you do a picture out of this? Like if you made it the right equation, could you do like a smiley face or something?
that is exactly what happens. Yeah.
Cool. I want to do that now.
Yeah, and they get really complex. I want to show you some extra ones if we have some time. So 2x, so let's plug in, I don't know, 0, 0, this first one. When I plug in 0, 0, it has a slope of 0. What about 0, 1? Has a slope of 2 now.
0.5.
Wait, no.
Oh, that's, I went all the way over here. Yep,
Wait,
sorry.
It's actually not 2 because 0 gets flipped, so it's still 0.
Because it's x value.
So the x-coordinate right here is 0.5, right? When I plug in 0.5, what is the slope?
It's 1, but you said it was 0.
Oh, that's my bad. I did not mean to confuse anyone. And if it helps you in your notes, you can say, oh yeah, that was 2. On the actual AP test, you don't actually have to write down the number. That was a slope of 1. That was a slope of 0. What happens if I do negative 0.5? I get a slope of, shout it out, negative 1, graph that. And then negative 1 will be a slope of negative 2, yeah. What happens if I go to the x-coordinate 0, the y-coordinate 0.5?
0 again.
0 again. What about the point 0, comma 1?
0.
What about the coordinate 0, comma negative 0.5? 0. And take a wild guess. 0. What happens if I go to the point 0.5, 0.5? Slope of 1. Are you guys starting to see the pattern here?
This is cool.
Go ahead and fill in the rest of these points. Notice that since this equation does not have any y in it, it only has an x, it's only going to be dependent on the x-coordinate, which means only dependent on left and right. Up and down are going to be the same slope. So if I have a slope of negative 1, all of the up and down are going to be a slope of negative 1. And that was negative 2 in that case. So those can go nice and quick. I can actually copy paste. Technology is lovely like that. Paste the slope of 2. Paste the slope of 2. Paste the slope of 2. Paste the slope of, well, these are all negative 2. I don't know why I'm saying positive 2. Paste. This might actually be slower than just writing it down, I'm realizing.
Usually, but they're all the same slope.
They're
There you
exactly,
go.
and they're the same length too, because they're pasted.
It's slightly more aesthetic.
Ah, go that way.
Yeah.
Yeah, I mean, if I spent the time, I could make them really, really
Yeah,
nice,
you
right?
just deleted them all.
Oh my god, what just happened? No! Oh my god. Okay, I'm just going back to pencil. Just. Oh my god, that is annoying. All right. So what's actually happening on the real graph? So this I consider the slope field, and you can label that. That is your slope field. But what actually happens on your graph? And let's just take the antiderivative, right? So I want to graph f, or a graph y in this case. Y is equal to something. So in order to find y, I have to take the antiderivative, right? I'm going back to the integral. So what is the integral of 2x? 2x. X goes to the power of 2, divide down 2, and that's equal to x squared. Forgetting. There it is, plus c. This is the equation x squared plus c. And that's why I have a bunch of these parabolic shapes. I have a parabola right there, a parabola right there, a parabola right there, a parabola right there. I can move, if I had a slider, I can go grab one really quick. I can move this parabola up and down. So let's go ahead and, while we're here, go to Desmos. And I'll show you all the possibilities that you could have. Well, at least all of a relative number. Start graphing. Essentially what I have is, come on, go computer. I have x squared plus c, and I'll need to add a slider for c. And I can drag this slider up and down. That's all of these are represented on the slope field. And I can make this projector view so I can see it a little bit better. Every single one of these parabolas is now represented in that slope field. For example, if I were to pick a point here, then I would know that, okay, well that one is the equation of x squared, which means I go right one up 1, then right one up 3, then right one up 5, then right one up 7. You go up by odd powers, right? And that would be, I can use a different color here. If I just chose an initial point, I would be able to figure out, oh, well, since I know my initial point, this c has been changed to 0, I can now say, okay, well, this is the equation that goes like this. All right, so that's kind of the idea of slope fields. Just make sure you get the steepness correct, and you should be good. Questions? Give me a fist of 5 on our objectives. 4, 4, 5. All right, cool. That concludes the lesson.